Awesome. How's it going? Can everyone hear me okay? Cool. So how's day 2 going? Thumbs up, going well? Everyone going great? Nice. Great to see everyone. My name is Bar Moses. I'm going to talk about the next big crisis for data teams. I like to think that in data we're sort of like the cool kids party. I was never part of the cool kids, so this is my chance to make it. But the thing about this cool kids party is that we keep on getting hit by crisis after crisis. It feels like more so in the last couple of years. And so today I'll talk about what I think is the next big crisis for data teams and what are some of the ways in which some of the best data teams are actually dealing with that. So just a quick intro about myself. My background is in data and analytics. I'm actually originally from Israel, moved to California about 15 years ago. It's my pleasure to be here for the first time at this conference. We started the company Monte Carlo and pioneered the category of data observability 4 years ago in 2019 with the premise that just like every single engineering team is responsible for building highly scalable, reliable infrastructure and applications, every single data team should be responsible for delivering the same level of trust and diligence for their data products. And those solutions didn't exist today. In fact, didn't exist back then. In fact, even the word data observability didn't exist back then. People actually told me that it's a really difficult word to pronounce. English is my second language, so it was doubly hard. And here today we have a full track at this conference dedicated to data observability. So it's really cool to see how far the category has come in the last couple of years. And a lot of that is thanks to our amazing customers who partner with us on creating the category, including several folks who I've met here today, including Checkout.com, Jaguar, JLR, Ovo, Tenable, and many others. So a big thank you to the customers and partners who are on this journey in creating this category. So today, what are we going to talk about? It's very hard to do a presentation today without talking about generative AI, despite my reluctance. And so I'll talk a little bit about, what does that mean for data teams? And I think in a way this presents a ton of opportunities, but also a certain crisis for data teams. I'll speak a little bit about what that means. And then what is also the future of building reliable data and AI systems? Just curious by show of hands, is anyone who's doing something with generative AI today? Wow, so few people. That's so interesting. Such a small percentage. It's interesting that dissonance, right, between how crazy the hype is around it. I don't think there's a single person who hasn't heard something about generative AI, and yet there were only 3 people in this entire room, maybe 3 if I counted well, who actually are doing things in that with generative AI today. And I think that speaks a lot to this kind of crisis. There's a very, very high amount of expectation for data teams. A lot of them are sort of top-down driven, and data teams are really sort of finding themselves scrambling, trying to find real use cases and real applications. And so folks maybe like me find themselves sort of scrolling through Twitter and asking themselves, is this just a demo or is this actually something real? And also asking themselves, what does that mean for the future of my profession? And should I do anything different when I wake up tomorrow morning? I think today there's a lot more questions than there are actually answers. And this is my favorite all-time GIF, just in case you were wondering. My hot take is that, at least in this current cycle, generative AI will not replace data engineers. And actually, in data observability in general and sort of our thinking, I like to use corollaries from software engineering because I think we can look to software engineering as an industry that has come a long way in the last couple of decades and draw corollaries to data as a space. And if you look at software engineering, we've come a very long way in terms of productivity for software engineering, right? Sort of the journey from assembly to Python has been a long journey, but has made engineers 10x or more productive, and we are not seeing less software engineers. In fact, we're seeing more software engineering and more software. And I think the same thing will happen with generative AI. It's making its potential to make data engineers a lot more productive means that we will have more data teams, more data applications, and more data challenges, but not less. But maybe if we ask a ChatGPT, it will tell us something else. I'm not sure. It does, however, I think present some real opportunities for and challenges for data teams. So while only 3 of us are actually doing something with it, we are facing it on a day-to-day basis. And I think in the question of how to actually make this useful, we have to ask the question of what are actually the results. This is actually my favorite AI fail, if you will. And we see a lot of this, right? And so the question of how do we actually leverage this in a way that moves us forward, as an industry, we have a responsibility to figure that out. So this I thought was this is courtesy of Chip Huyen, and I think, this was sort of an interesting list of the open challenges in LLM research. And there's a fairly sort of, robust list of things to figure out here and a good amount of research that's going into this. I found it interesting that the top issue is reduce and measure hallucinations. So the definition of hallucination, or sort of the way to think about this, is, confidently produce incorrect results. And the issue with that is that we often conflate high confidence of incorrect results with well-reasoned arguments, because that's how we are as sort of human beings. If someone will tell us something with a high degree of confidence, even if it's inaccurate, there's a very high likelihood we will actually believe that. And that actually, presents a whole different set of challenges. But the underlying problems are not just the hallucinations. It's also that generative AI is only good as the data that powers that. And so we work with tons of data teams, and the number one question that I ask them is, are you doing anything with generative AI? And then most of them say no, and then the second question is, why not? And the very top of the answer is because we are worried to put it out in the wild and worried about the brand and the trust of us as a data team when we put something out there. Time and time again, that is a top challenge that comes. And so I think, all of these problems are actually not new. So while none of you are perhaps doing anything with generative AI, we're all dealing with the same problems that have existed for the last decade or so. But I think generative AI will accelerate some of these problems and make a lot of them sort of show up in a much bigger scale. So we talk about data governance, for example. I think that's like maybe the most loved and hated word at the same time. I might be starting the anti-governance movement and actually bringing it back. I think it needs rebranding. So if anyone has a better idea for how to call data governance, let me know. But I think data governance is going to become even more important in this age of generative AI. It's going to be even more important in terms of scale. And I think some of the questions that data teams are going to have as sort of the stewards of good data is, how do we find the right data sets? How do we measure the quality of those? How do we make sure that those feed the right models? How do we make sure that the models over time are training and accessing the right data? Those questions are hard to answer even without generative AI. So think about how much more complicated it will become when we introduce that into our lives. I will say, we sort of coined this term data downtime as sort of a way to explain what bad data looks like, again, as a corollary based on software engineering. So in software engineering, we sort of call application downtime or infrastructure downtime, and engineering teams measure that pretty religiously, right? Like everyone knows, if they have like 5 nines or 6 nines of availability. My favorite example of this is when Netflix was down for 45 minutes in 2016, it was actually down because of bad data. I can't imagine Netflix being down for 45 minutes. I don't know about you all. Pretty big fan of some of those shows out there. Survivor is maybe my top hit, and if I were to miss a full episode of Survivor, it seems pretty consequential. But in all seriousness, there are some grave consequences for businesses. These are examples that are based on bad data feeding machine learning models. So the first example is actually Unity, which is a gaming company, which had to publicly report a loss of $100 million because of one mistake in a machine learning model that failed. There's a lot more examples like that just don't make it to the newspaper. The second example has to do more with sort of social implications. So Equifax is a credit score company that actually assigns credit scores to people that allows them to take mortgage, to take loans. And when the model, there's basically machine learning models that assign those credit scores based on demographic and historical information. And when that data is wrong, it means that the credit score that you might be getting is wrong. So that means millions of people that were denied loans, denied applications because of a mistake in data. Another example is actually in COVID. So in COVID times, there was reports of actually like deaths and impact of COVID, and that was also misreported many times because of issues in the data. And so our ability to help people and to drive better healthcare overall is impacted by this too. Now, the interesting thing that we've learned based on working with hundreds of organizations who are facing with this, I don't think there's a single company that hasn't experienced data downtime. Maybe I can actually ask, because who here has experienced bad data or data downtime, by show of hands? For those who haven't raised your hand, I'm so curious to know what you're doing. Would love to chat with you after to learn. Maybe we can improve something. You know, one of the interesting things that we find in sort of data downtime, when data is inaccurate or wrong or late, is that it sort of cuts across industries. So, you know, there's probably data teams here from e-commerce, from retail, from media, from tech, from various industries. And whatever sort of sample you take, bad data sort of influences that. And the interesting thing, which, you know, sort of points out here, is that there's a correlation between the amount of time that the bad data exists and actually its consequences, sort of time to detection over consequences here. And I think when data engineers find the issue, which, by the way, is the most rare case, you know, obviously there's sort of lost time. But many times, data engineers actually learn about the data problem when they hear about it from the marketing team, or from the customer success team, or someone on the product team pings them on Slack and Teams and says, WTF, what happened to this report? And you're like, I don't know, beat me, right? It's not my report. I didn't set it up. But guess what? You're on the hook to explain. And so there's lost trust between those teams, right? And in today's world, everybody's using data. So it's like all of your business stakeholders, there are data teams that get, you know, 10, 15 of those pings every single day. That is a difficult reality to live in. Oftentimes, more and more companies actually build applications based on data that are being surfaced to their customers. Maybe this is, you know, a digital app that sends you information about your health today. When that information is wrong, you're making the wrong decisions. Maybe it shows you that you slept more or less. Maybe it makes a recommendation for a specific treatment that's inappropriate for you. When that data is surfaced to external customers, you lose revenue, and worse, when it's exposed to the general public, you lose reputation. And so there's actually grave consequences over time. And for data teams, I think a lot of the question is, how can we flip this? So how can we get to this place where data engineers are actually the first to identify issues versus learning about it from there? I think the reality is most teams, even if they don't want to admit it, are actually closer to the top here. And if we want to make any advances with data, generative AI or not, we need to move down the curve. And we need to do that pretty quickly. And I think there's a lot of pressure to actually figure that out very quickly. The additional problem based on that is that data now powers every single thing that we do. Guess what? There's a bad data problem in one issue. There's probably 20,000 applications that rely on that. This is just a screenshot that I took to show, I think this was like the tech and data stack. If you squint, maybe you can see your company somewhere here. But this is kind of ridiculous, but this is true, right? I mentioned I was on a panel yesterday. It's not uncommon for organizations to have tens of thousands or even more of applications. It's like, you know, I'm not sure, X applications per employee per head count, right? And yes, there is some consolidation and rationalization that's happening, but think about the implications of one bad data issue and how that sort of propagates across the tech and across the stack and touches more and more organizations and people. The last point that I'll just make on this is that, you know, if you look at some of the strongest players in the space, Snowflake and Databricks, but also some of the leading cloud players, they really, you know, they're investing heavily in generative AI. You see that in their keynotes, you see this in the business plans. There's a lot that's happening, specifically around the idea that enterprises will be able to fine-tune and use LLMs in production through their stack. And both of those actually agree that, you know, at the heart of this revolution is sort of high-quality data. So I like this sort of quote, you know, you cannot indiscriminately let these LLMs loose on data that people don't understand. That is what we are doing right now, and that is a shift that we need to make. The second quote here is that the quality and the safety depends so much on good training and data that's being accessed. So this is a, sort of a problem that's shared across the industry, across teams, across organizations. And then the question is, how do we start dealing with this? There's various ways to do this. One of the things that, obviously we think a lot about is sort of data observability. I think when we look about how this category has emerged in the last 3 years, 3 years ago there was very little language, as I mentioned, to actually talk about this and describe how do you think about trusted data at scale. When I think about my personal experiences 5-10 years ago, first of all, data was used in a very, very small silo part of the organization, mostly to report on numbers at the end of the quarter. So we had a full quarter to look at the numbers again and again. There were maybe, 6 sets of eyes that all sort of rolled into a data manager or some person who then looked at the data again, and we could make sure that everything is accurate so we report the right numbers at the end of the quarter. It was a full, all hands on deck to make sure that that report was right. So data was siloed in a specific part of the organization for a specific use case that we could manually look at. That's just not the case today, right? This is a far cry from where we are today. Many of you, have heard some of the common things that folks are doing. They're working on migrations to the modern data stack. They're moving to the cloud. They're building more and more applications with data. You're not just using numbers to report to the street. And so in that world, you actually need to make sure that trusted data is at the heart of what you're sort of doing. I think when in that world where we're sort of manual and we're able to look at it, on a per report basis, we could actually get away with some of the data being wrong. And that again is no longer the case. In today's world, it just doesn't fly. And so we have to start thinking about some of the scalable ways to do this. 3 or 4 years ago, there was very, very, very little language to describe what goes wrong with data. It seemed like we had no idea why, we just knew it was wrong. I think today we can say data is wrong based on 3 different categories of things that change. The first is there can be changes in the data itself. So someone can manually change the data, or it can change sort of in format and type. The second is there are changes in code that actually implicate bad data. And the third is there could be changes in infrastructure that cause data downtime. And it's actually really complicated to think about how do we create observability or health of the data across those 3 measures. But I think that's the scalable solution that we have to go and start figuring out how do we do that. I'm not saying that the solution is out there today, but I think that's a solution that we need to build towards. And if we have a really robust and scalable way to think about observing healthy data across code, infrastructure, and data changes, then we'll be able to live in a world where we actually have trusted data that can serve sort of both a data and AI stack. What are some of the things that are working today? It's not only bad news. There are some things that folks sort of actually are using and we're seeing out there. So I'll talk about 5 things that we've seen sort of work time and again. The first is what we call the 5 pillars of data observability. I speak with sort of hundreds of data teams, and the most common thing that someone will tell me is, an engineering team upstream made a change to the schema and it just messed up my entire data. And by the way, that happened on a Friday, 5 p.m., right before I was heading to the pub. So I really had a great time. It was awesome. The entire weekend I had to work through it, and all of my friends at the pub just missed me. I don't know why it always happened. Those engineers are waiting for Friday, 5 p.m., right before you hit exit to make that schema change. It actually makes sense in some world, but the idea is schema changes create a lot of havoc. Some other common things, to sort of enumerate these 5 pillars. The first is schema changes. The second is freshness problems. Many organizations rely on third-party data. Guess what? That party doesn't arrive on time. That data doesn't arrive on time. The third party is not going to tell you that it hasn't arrived on time because they don't even know about it. Very common. The third is volume. So while the data might arrive on time, maybe only half of it actually arrived, only maybe 2 rows out of 100. But also, by the way, you're not going to get notified about that. And so your job is correct, check, 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 but Friday, 5 p.m., the report is not loading. The fourth and more sort of, traditional pillar is what we call data quality. And so that's really, sort of at the field level, different values that might show up in different ways that you expect. And then the fifth pillar of data observability is actually lineage. I think lineage, I don't know about you all, but like 5-6 years ago when I was dealing with data downtime issues, me and my team, we had to like figure out why something broke, and we walked into a room, and we actually sort of mapped on a whiteboard all the different sort of paths that a specific data report is taking. And then I remember reaching out to a friend, and she's like, yeah, we have like 30 people who are like mapping the data for the last 3 years. That is what many of you might have been doing or are doing. And in today's world, we can't really do that with our data pipelines. And so actually having strong automated data lineage that helps across the tech stack is becoming something that's sort of foundational to understanding the health of the data. And the power of these 5 pillars is in the most robust systems is that they come together. So we can actually start piecing together and understanding what broke and where and for what are the implications and why. The second big change that I'm seeing as it comes to sort of trusted data is actually using machine learning for monitoring and detection. Historically, many teams actually sort of write manual tests. There's, a large number of people that I've spoke with here yesterday who tell me, yeah, we have like 200 tests that we wrote or 1,000 tests that we wrote. I think that's great. I don't think that it will be replaced. But I think going forward, we have to lean on some of the innovations that we have, like machine learning, to actually develop some of these monitors in an automated way that doesn't require human input. So actually, by observing the data over time, you can define specific or in an automated way, determine thresholds and actually create alerts for data teams to understand when the data goes wrong. And that's without any input. And I think starting with that as a baseline then allows teams to actually create a customized view from that. Again, I don't think data engineers are going to be replaced. It's very hard to actually understand for machine learning to really truly understand the business or, the specifications in your way. I work with someone who, their CMO wanted their, they would wake up every morning at 6 a.m. and they would drink coffee at 6:15 a.m. And while drinking coffee, they would look at the reports. And so at 6:15 a.m., the data better be right. And so, that's a specific business of, I don't know, maybe some chatbot one day will, loop into your coffee habits. That could happen. But as of now, you know that. And so you know that by 6:15, data has to be fresh, on time, and accurate. And so actually being able to specify that is sort of the next thing. But I think it has to start with machine learning to reduce the load on data engineers today. The third thing is root cause analysis. This is actually something that not very many teams do. So oftentimes teams are like, oh shit, there's a data problem, let's go fix it. But actually going to understand why is the data wrong, what happened, and being able to change what happened so that in the future it doesn't happen again, that requires a mindset shift. That's not something that very many organizations do today. How do you actually start that journey? I think the very first thing to do is ask, when something is wrong, who is impacted, right? So something is late, maybe your CMO is watching that, and, you don't want them to start with a bad start for their day at 6:15, so you want to make sure. But maybe there's a data set that nobody's looking at. And in those cases, maybe you don't even care about that. And so actually being able to understand what are the implications downstream. And then also, flip side of that is going upstream to understand what is actually the issue of this. So we work with a data team, and they found that 80% of their issues is actually resulting in one upstream engineering team among a group of 40 engineering teams. Of course, there's a lot of finger pointing, everybody likes to blame, etc. But when you can trace down the issues and pinpoint it to a specific source, a specific type of data, a specific team of data, that can significantly increase the resilience of your data team. And so over time, you build additional metrics to understand what are the most common sort of issues that we have with the data, and what are we doing to actually address the root cause to begin with? Just being sort of reactive to these data issues won't get us so far. The fourth thing that I'm seeing data teams is, sort of think more about is actually like data product. Katie Russell yesterday did a panel with her. She's director of data at OVO Energy. And, I asked her, what does data product mean for you? And she said data products is actually a way of thinking. And I love that because I think that's very accurate. A data product is it's not a specific technology, it's not a person, it's actually a way of thinking in which data teams build products and build teams. And that means having data product managers who own a full set of assets that contribute towards a particular use case. And as we start building data pipelines in this way, can we start thinking about the health of the data pipeline as sort of a derivative of the data product itself? Actually starting to build, what you can see here is basically like a view of health of a specific data product. That's a very new way of thinking for many data teams and many organizations. The last thing that I'll mention, or the fifth thing that I'll mention, is I think cost is top of mind for everyone these days. Yesterday at a panel, we asked sort of like how many folks are rationalizing. I think 100% of the audience raised their hand. And so cost is sort of being thought everywhere. I think there's various ways to thinking about what does cost mean. The first is, are we actually using the data that we have? We have been hoarding a ton of data. Then we were hoarding a ton of metadata. Now I'm not sure what we're doing, but there's a lot of it. And are we actually like optimizing or doing it in sort of a thoughtful way? The second, and this is the example here, is are we actually optimizing the queries that are running on our data, right? There's sort of looking at query runtime as an example. So kind of like easy ways that folks look at cost optimization over time. Definitely something I see a lot of teams do. And the bonus, I think, I spoke a lot about why data trust is important for generative AI, but I think the cool thing here is that actually generative AI can make data trust and data observability a lot easier as part of making data engineers more productive. And I'm really excited about that. So in this particular example, you're actually seeing generative AI helping a data engineer create a custom monitor, so create a sort of SQL query for the data. And actually the SQL, the query itself is wrong. And so with generative AI, we can suggest a fix for the query. In this way, allowing data engineering teams to be much faster in actually creating monitors and understanding the health of the data. And you can imagine a world not too far where you can, in natural language, ask, what is the data set that I should use? What's the stress score for this particular data asset? Is this data on time? Is this data accurate? I hope by then we figure out, our confidence in generative AI. It's, becoming this very meta problem, as you can see. There's a lot of things to figure out here, but I do think that's sort of where we're heading in the future. The one question that remains open and is not resolved by any generative AI or any technology is the question of ownership and incentives. Whose neck are you choking? Whose neck are you standing on when there's a data problem? Who gets fired when data is wrong? I don't know. I'm not sure. It really varies. There's lots of people on the hook to deliver data. A lot of people don't want to do it. I actually think it's a great opportunity. If you can solve this problem for your organization, by the way, I don't think we can get to 100%. Those of you before who didn't raise your hand, I'm watching you. I don't think that's true, or at least I want to know how. I don't think we can get to 100% accurate data, but I think we need to make damn sure that we're improving and we're making significant steps to get there. And that starts by asking who's actually responsible for it. This is a diagram that shows sort of different teams and their incentives. There's a lot of different ways to do this. Some people have, data analysts, data engineers, engineering teams. They all have their hands in data. Guess what? It's going to get worse because now with generative AI or other advances, everybody's excited about data. So even if you're an engineer and you weren't dealing with data, some chance, flip of a coin that you will be in the future, right? And so what does that mean about the skills that people have to learn? Maybe generative AI can help with that too. I think this is a question that we still haven't figured out, and not sure tech will help us. I think I have one more minute, so I'll end with this, which is one of my favorite slides as well. You're not alone. I know it might feel like you're being crushed by a big force. At least that's how I feel sometimes. But every data engineer is facing this. And I actually think the great beneficiaries of this revolution, whatever it may be, small or large, long-term or short-term, are data teams. I wasn't kidding when I said I think this is like the cool kids party. I don't think there's an industry that's more interesting to be in. I don't think that there's more interesting challenges to figure out. And I also don't think that there's an area where we could make a bigger impact. And it starts with solving some of these challenges, which are real. But I personally get excited about, solving some of these hard challenges, especially if they lead to really great impact. So I'll leave you with that. I hope, wherever you are in the journey, you find meaning in sort of solving these challenges. I think it's a worthwhile fight to fight for, and I hope you're able to make a great impact with the data, with trusted data, wherever you are. I have a shameless plug for a conference that we're doing. We're happy to see you there. And I will be at booth 420 if folks have any questions. Thank you so much for the time today. Really appreciate it.